All right, 5-2, verifying trig identities. Now, a lot of what you're going to see in this video is going to look very similar to yesterday's video, but the main difference here is now we're actually going to have an equation. Of course, the difference between an equation and an expression is an equal sign. Okay, so now we're actually going to have equations. So now we kind of have something that we know we're going to be working toward. Whereas yesterday, you kind of just had to keep going until you're like, well, I just can't do anything else now. But now it's going to give you something to work for because you have to be able to prove that both sides of the equal sign equal the same thing or equals one of the three golden rules. Okay? So the only time you won't have the same thing on both sides is if you prove it down to a golden rule, which we know is already proven. All right. So let's try some stuff here. So basically what we're doing is we're doing some proofs. Okay. So we want to prove that sine x times cosecant x equals 1. How are we going to do this? Well, let's try to rewrite everything in terms of sine since we have a sine right here. So we know cosecant is 1 over sine. So this is sine of x times 1 over the sine of x, and that's going to equal 1. Well, when you multiply sine of x times 1 over sine of x, if you make this into a fraction, these two will cancel, giving you 1. So in this case, 1 equals 1. Yes. Okay. So now, like I said, it gave us somewhere to work toward because we had to know that we needed to get this to equal 1. All right, so we had to somehow try to prove this equals 1. All right, so we took the cosecant, took the reciprocal, 1 over sine. The signs cancel, giving us 1 over 1. All right, let's look at another one. We want to prove that 1 plus sine x times 1 minus sine, oops, I left my x out. I do that a lot. Okay, equals cosine squared x. Okay, we need to prove this. So what are we going to do first? Well, here you notice we have two binomials. Okay, you can think of these as x's. So we have 1 plus x and 1 minus x. So let's fold this thing together. Okay, 1 times 1 is of course 1. 1 times negative sine x is minus sine x. Sine x times 1 is positive sine x. And then sine x times a negative sine x is negative sine squared x. And that's, of course, going to equal cosine squared x. All right, well, if you look, plus sine minus sine, those cancel, leaving you with 1 minus sine squared x equals cosine squared x. Now, in this case, instead of trying to keep going and simplify this down to cosine squared, what we can do, since this looks like it could possibly be one of our golden rules, okay, if we add sine squared x to both sides, okay, that gets rid of it over here, moves it across. So now we have 1 equals sine squared x plus cosine squared x. And in fact, that is the first golden rule. 1 equals sine squared x plus cosine squared x. Okay, so like I said, this is giving us something to work toward. Now, if we'd wanted to, we could have solved this to do cosine on both sides. In fact, I'll do that over here, because if you have the golden rule and you subtract sine from both sides, you have 1 minus sine squared x equals cosine squared x. So in that case, you could have said cosine squared x equals cosine squared x. All right, I will take both of these as correct answers. It just depends on which way you want to go when you get to this step here. If you want to make it look like a golden rule, go ahead. If you want to put the same thing on both sides of the equal sign, go right ahead as well. They're both correct. All right, and one's not more correct than the other one. They're both perfectly fine. Okay. All right, now I want you to try one. You try. IOUDR. All right, I want you to prove that cosine squared x minus sine squared x equals 1 minus 2 sine squared x. All right. I'll give you a little hint on this one before I turn you loose on it. Think a golden rule. Go. All right, so let's give this thing a shot here. All right, so we have cosine squared minus sine squared equals 1 minus 2 cosine minus 2 sine squared x. All right, so let's get all the sines and cosines on one side to see if we can possibly make this thing a golden rule. So let's add the 2 sine x to both sides. All right, so the cosine squared is not affected. But now you have negative sine plus 2 sine. Okay, of course, that's going to go down to plus 1 sine squared x equals 1. And what is that? That, my friend, is a golden rule. All right. Even though the sign usually comes first, since they're both positive, the order here really doesn't matter. Okay. Hopefully you got that one right. All right. This one's also going to be a you try. I want you to try this one as well. Okay. But can you kind of see how it's given us something to work toward? We're not just kind of going along, going along, going along, and then what? Well, I can't really do anything else. All right, this is actually giving us, a goal in mind. That's something we can see. Okay. All right, go ahead and solve this one. I'm not going to give you any hints, but go ahead and solve this one. All righty. So if you look, we have tangent squared plus 4 and equals secant squared plus 3. I left my x out there. Let's see if we can make this a golden rule. So let's get this 3 over here because we know tangent squared plus 1 is secant squared. So let's get rid of this 3. So now we have tangent squared x 4 minus 3 plus 1 equals secant squared. So there we go again. Oops. Another golden rule. Okay. Now you see why it is important that you remember what these are. Okay. Because when you're doing this, there's no need to try to simplify that any further. We know it's a golden rule. We'll just leave it alone. We're done. We don't have to do any more work. All right. Now let's do one more. Sine squared x minus sine to the fourth x equals cosine squared x minus cosine to the fourth x. All right, so how are we going to solve this? All right, think about it for a second. What should we do first? All right, hopefully you said something about about either factoring out a sine squared or a cosine squared. So that's actually what we're going to do because you have sine squared on both sides of the minus sign. So let's go ahead and factor that out. Sine squared x, that leaves us 1. Because remember, you're technically just dividing all this by sine squared. So you still have to have a placeholder. So this is 1 minus sine squared x. And if you want to double check your work, just distribute this back through. Okay. If you didn't leave this 1 in here and you distribute it back through, you wouldn't get this sine squared x term here. All right. And then this side's basically going to look the same way except for cosine. 1 minus cosine squared x. All right. So now, this looks like it might be a golden rule, right? Well, if you remember, I'm going to abbreviate here. You have sine squared plus cosine squared equals 1. Well, if you subtract the sine squared from both sides, you have cosine squared equals 1 minus sine squared. So look at that. This is cosine squared. All right. So now we have sine squared x times cosine squared x. And that's going to equal our cosine squared x. All right. Well, now, if I erase this minus sine squared x, and we subtract the cosine squared from both sides, you notice that's what we have here. Okay, so sine squared equals 1 minus cosine squared. So now we know that this is sine squared x. Okay, and as you can see, we now have, they're not in the same order, but we now have the same thing on both sides of the equal sign. So therefore, we are finished, and we do not, and there's really, you really can't combine these anymore because sine squared times cosine squared doesn't equal anything else other than sine squared times cosine squared. So we can't simplify it any further, so we're finished. All right. So as you can see, this video is pretty much the same as yesterday, except now you have a goal in mind that you need to be working toward. All right. I think the equations are a lot simpler than the expressions because of the fact you know when you're finished. When you get the same thing on both sides, or you end up with one of the three golden rules, you know you're finished, so you don't have to go any further. Whereas what we did yesterday in class, you just had to go until you couldn't think of anything else to do, and then you just like, okay, I'm done. All right, so I think the equations are much easier than the expressions. All right, so make sure you understand these. Most of y'all did great yesterday with these. So come tomorrow ready to do some more. Have a good one.